To mitigate peak flows on a project, we need to add what is called in InterHyd a control device. So I'm going to first zoom in towards the outlet, and we're going to assume that this is going to be the control manhole for our site. And then under our component panel, I'm going to click on the control device button. And this is going to give an icon, which I can click to add into the scenario. And then with the blue link, just like we did with catchments, you can assign it to a node. And basically what we're saying is inside this manhole, this control structure, there is a control that is active. Now, if I click on this, you can see here there's a whole bunch of properties associated with control. So we're going to go through these one by one. First, you can specify the type. It could be an orifice, it could be a weir, you can define your own custom rating curve, or it could be a constant discharge. A constant discharge would be, for example, if you have either a pump, or let's say there's a future development upstream where you know what the peak flow needs to be, but you don't yet have the exact orifice size. For this demonstration, we're just going to keep it as orifice, and I'm going to rename the control to just say orifice number 1. Because it's an orifice, you can choose whether to have a rectangular or a circular orifice, as well as the orientation. In this case, we're just going to keep it as vertical. And we can actually specify the location. So you can see when I click on this, it says either the pipe to head wall 1 or the pipe to manhole 3. So if you think of this as an orifice plate, the orifice is going to be located on the openings of one of these pipes. And you can actually specify which pipe it's acting on. Now, this is very important because if you have multiple pipes coming in, the location of that control will govern which catchments are controlled, as well as which structures, so pipes, manholes, catch basins, are providing storage. InterHyd is automatically going to account for structure storage upstream of a given control device. Now the next field is called relative to. And you see when you click on this, it's saying invert, top, or fixed elevation. So keep in mind that because InterHyd is updating the design of your storm sewer, the orifice might actually need to adjust to match into the inverts of your pipes. So if we have this set to invert, you can see here the invert is set to 200.21 and it's grayed out. I can't edit that. The reason for that is right now it is connected to this downstream pipe, and that pipe has an invert of 200.21. If I were to switch the location and put it on the upstream pipe, manhole 3, you'll see that the invert is now 200.24, which matches the invert of the upstream pipe. You can set a relative invert to this. So let's say you wanted it to be a little bit higher up. You can do something like relative plus 0.2, and then that invert is going to be 0.2 meters above the invert that you are relative to. I'm just going to set that back to 0. Diameter, of course, in this case, we're just doing a circular orifice, so we can set the diameter. I'm going to set this up to 250. You can adjust the orifice coefficient. And then finally, we have another one called the overflow. So think of the overflow as the maximum high water level in the system before it's going to hit the top of the control and start spilling out as an uncontrolled flow. In this case, I've got the overflow relative to the top. So we're basically saying the overflow elevation, 202.23, is equal to the top of this manhole. But if you are working in an industrial site or commercial site where you might have parking lot ponding above your control manhole, you can actually set this overflow to be a relative amount. So I can say something like plus 30 centimeters, in which case the overflow elevation 202.53 is 30 centimeters above the top of your manhole. And you can also set a negative relative amount. So overflow of minus 0.5 would be equivalent to applying a 50 centimeter freeboard. And you can see here our overflow elevation 201.73 is now 50 centimeters lower. These other options would be if you want to have it relative to the invert. So that would be the invert of the orifice. You can specify, let's say, a maximum storage depth of 1 meter in your system. You can set it like this. So the overflow elevation is now 201.21, which is 1 meter above the invert. You can also set it to a fixed elevation. Let's say you have a residential development with basement connections, and you might know that to ensure that there's no backwater going into those basements, the maximum HGL has to be 201.5. You can set that in as a fixed elevation. I'm just going to set it back to relative to the top. And then the last two items here, it's going to tell you the total depth that's operating up to the top of the overflow elevation, as well as the total volume that is being provided upstream in the storage that's provided upstream in the structures up to that overflow elevation. And now that we've provided a control, if we go back to our results table, you're going to see that our proposed scenario has now been broken up into an unmitigated and a mitigated scenario. So whenever you've added a control to a scenario, it automatically adds a split between a mitigated and an unmitigated. And we can see here under the mitigated scenario that there's a lot of red. And the red is InterHyd's way of telling us that there's a problem with the current design. To better understand exactly what's going on, we can click, let's say on this last one here, swim summary for specific storage groups. In this case, this is going to show us the results for the storage that is defined, or I should say controlled by our orifice number 1. And what we can see on here is that for each event, it's going to tell us the unmitigated flows coming in and out, the high water levels, the discharge from our orifice, and then as well as the storage volumes that are required and provided. And in this case, we can see that we are not providing enough storage. So as a result, the high water level is going up until it hits the top of our control manhole. That's the overflow that we have set. And any flow that exceeds the amount that's being discharged from our orifice, so basically this number minus this number, is going to be the overflow amount. And InterHyd will always count an overflow in this column as an issue with the design, because if you actually want to design a proper overflow, let's say you've got like an emergency weir or a second stage orifice, you can add multiple control devices and they will show up in this column.